Hi, so I'm going to go ahead and solve the fourth problem for us. Okay, we have 27.8 grams of potassium iodide dissolved in 60 grams of water. Our temperature changes from 27 to 13 degrees Celsius. So, did we get colder or did we get hotter here? Okay, what happened? Did we absorb energy? Did we release energy? What is going on? All right, so we want to know what the delta H of this reaction is, and once we calculate the delta H of this reaction, we'll be able to tell if this is exothermic or an endothermic reaction. So let's go ahead and do that. Since we know this is a calorimeter reaction, we're going to take the Q, which is our thermal heat transfer of water, H2O, and calculate that. So we know that this is equal to mc delta T. Our M for water is our mass of water, which is 60 grams. The specific heat is always 4.184 joules per gram degrees Celsius. And our change in temperature is going to be 13 minus 27 degrees Celsius. Okay? We're going to calculate our problem, and once we calculate this, we end up with negative 3,514.56 joules. Now, this is the Q of our water. We know that Q of the reaction and Q of water are equal, except that one is negative, of course. Okay, so if these are equal, and this is my Q of the water, well, I have to carry out this negative, distribute it through, and it becomes positive. So therefore, my Q of my reaction is equal to positive 3514.56 joules. This is my thermal energy that was transferred from potassium iodine reacting with water to water, right? Okay, but that's not what we want. We want the standard enthalpy of our reaction, so the standard heat of our reaction. So let's go ahead and calculate the standard heat of our reaction, taking into account the mass, right? The mass that we used for our equation, which is 28.7 grams. So delta H of our reaction, we're going to start off with our energy. So what we do here is we take our Q of our reaction, we divide it by the mass, right, of whatever we reacted. So not of water, but of our product. So I'm going to put a P for product. And then we use the molar mass of our product to figure out, well, what we need. So we're going to multiply this by the molar mass of the product, and we get grams per mole. And this is the molar mass of our product, right? And then if we need to do any conversion factors at the end, we do a conversion factor right over here. Okay, so let's go ahead and do that. We have delta H is equal to this quantity over our mass. Our mass is 28.7 grams. We're now going to multiply that by the molar mass of potassium iodine, which comes out to 166 grams in 1 mole. Grams cancels out with grams. We're left with joules per mole. Okay, we can go ahead and calculate that, and we get a positive 20,328, I believe. Let's do that. Let's see if that's true. Okay. Actually, I think this was an incorrect one, but we'll see. Okay, 3514.56 divided by 28.7 times 166. Okay, positive 2328 joules per mole. All right. We don't want joules, we want kilojoules. So we're going to take this number and divide it by 1,000 in order to get our kilojoules. So we end up with a positive 20.3 kilojoules per mole. I chose 3 significant figures due to the fact that our grams were given to us in 3 significant figures. Our temperature was just a measurement, like a thermal measurement. And we could have reported our answer actually in 2 significant figures, which would actually probably be more correct. So it would be 20 kilojoules per 2.0 times 10 to the first kilojoules per mole, right? Yeah, Okay, I hope you guys find these helpful and enjoy the rest of your day.